Hi everyone, this is Vikas Singh Thakur and this is lecture 0 of our module 0, that is beginner friendly robotics course. In this video, we are going to understand the basics of electronics. Well, we are starting with the very beginner. So we are starting with the introduction to breadboard, how you can do the wirings, and we are not going to see only numbers or figures or theoretical part here. We are actually going to implement each of the circuit. And after the breadboard, we will also understand different resistor, capacitor, how to use them, which are very important in building basic circuit for your upcoming projects. I really want you to have all the components that I'll be using, and I have already built the essential video which you will be requiring to follow up the upcoming courses in the previous video. So you can just go there and check it out. So let's get started with the basics of electronics and let's understand different components related to it. So now let's get started. And before all of these, I really want you to have a notebook, a dedicated notebook based on your robotics course or whatever you want to give it a name. Always try to write down what you are understanding or the theoretical part or the points or all the key points that I will be mentioning here. And you can have a dedicated robotics notebook if you want, because this is something I really like to have, because you cannot just scroll down entire video just to find that exact particular note in an entire video. So you can just make a small notebook, a spiral notebook or whatever you are good with. Try to put all the theoretical part, all the circuits I will be showing you here. The first thing that we are going to learn is a breadboard. Well, breadboard are one of those very important I could say a tool in prototyping, because these are highly used when we are talking about electronics prototyping and when we are talking about those circuits for which we are not very sure about, but we want to just try it out. And these are highly reversible. That's why these are highly used in electronic prototyping. And here in the breadboard, there are three different parts that is needed for you to understand. So first thing is the power rail. So when we are talking about the power rail and row, column, central gap, and how we can what are the connection that is going inside this. So I have taken out the lower surface here or lower cover here, so that you can see the exact connection that is going in between them. So here you can see the first part, that is the power rail. You can actually take out most of the breadboard are actually detachable, and you can attach multiple breadboard with each of them to increase the overall area. So first part is the power rail. So here this is called power rail. The reason we call it power rail is because these are highly used in those cases where we want to supply a power to a breadboard or supply a power to the circuit. So here you can see when I flip the power rail, you can see there is two different connection which is continuously going on. So it means all of these side, all of these vertical gaps or vertical holes are connected with each other, and all of these next consecutive holes are connected with each other. So there is gap between both of this connectivity. So we can use one of them as a 5-volt power supply and another one as a ground. So we just need to attach it back to it, and we can give it a 5-volt, let's say 5-volt, and next one could be have a connection with a ground. And we can simply take out the connection from this power rail and we can put it to the main circuit or the main area where we will be going to attach our electronic circuit, like electronics circuit like resistor, capacitor, diode, or ICs, or any kind of microcontroller we want to connect with it. So this is the power rail, which is the first part. Next part is the row or column. So here you will see this is the actual area where we actually put our all the circuits, all the components into. So this is very important area. So here we need to understand how the connection is going on. So unlike the power rail where each of these vertical holes are connected with each other, all of these vertical holes are connected with each other. In the main area, all the horizontal rows are connected with each other. So here on this side, so all of these one, you could say here, you can see here, all of these are connected. And here we can see when we flip it out. So let's see here. So when we can see that all of these are connected, so it means all of these are connected. So all the horizontal holes are connected with each other, and next horizontal is isolated from the first one, and the same is going on through all of these. So you can see all this connection, and you will understand this. You don't need to memorize, or you don't need to take out the backside of it, but you just need to have some little bit of practice, and you will understand how all of these connections are going on. This is very easy, believe me. So this is one part, and next thing is the gap. So this is called central gap, which actually isolate the first area with the second area. So this area and this area are insulated. So if I flip it out, you can see these are connected, but over here you can see there is a gap. So all the connection in this side are connected with the horizontal rows, and all the connection on this side are isolated and then again connected in a horizontal row. So if I want to connect, let's say if I want to connect multiple of these holes, how can I do that? Now, if we want to connect all of these holes here, we can use two different options. First option, and my favorite one, and which is very popular, is this, using this jumper wires. So here there are multiple different, configurations of jumper wire available. So here this one is male to male. Here you can see the stripes on end of it. So using this, we can connect our breadboard circuit. And there is another configuration that is male to female in jumper wire, where one side we got the stripes and in other side we don't. So we can just put the connection inside this. So these are called female connectors, and these are called male connectors. So these are male to male, these are male to female, and another one, or another possible configuration is female to female, where both of the side have their endings and we can put the connector inside. So this is how this configuration is here. So male to male, male to female, and female to female. So these are the three configuration of jumper wire you can find in the market. And using this jumper wire, we can easily connect here. So let me build a small circuit here. Let me show you. So for example, if this is a resistor, first thing I want to ask you, can you tell me which configuration is the correct one? So if I do this, can you tell me which configuration is the correct one and which is wrong? Just comment down. It's a very easy question, and you can just do that to make it little interactive. So you can see that if you are saying this one is correct, this is wrong, this one is actually correct, because we have already seen that all of these are connected with each other, right? And when we are building a circuit, we are connecting two non-connected parts or non-connected terminals. So this, let's say this one, so this one and this one is not connected, and we are making connection between both of these. So this is right, this is wrong. And over the time, when you build all of these circuit from your side or from yourself, you will understand it much better. Instead of just watching it, it's not going to help you a lot. So try to have a breadboard. These are very cheap. Try to have some resistors and some diodes, capacitor in your bench, and try to build small circuits with yourself. And this will help you a lot, building this kind of project. So this is wrong, this is right, and I'm taking it off. And I want to, let's say I want to make a connection between these two resistors. Then how I can do that? So first way is to use a jumper wire. So take out one male to male jumper wire, because all of these connections here are female. So we require a male. So if I want to connect both of these resistors, then I can go with this terminal, and you can see this is connected with these lines. So I can just put it inside any of these. I just put it inside, and this one next here is connected with all of these. So I can just put this one, any of these. So it could be this one, it could be this one, this one, this one, any of these, not this side. So if I put this side, it is not connected, right? I hope you understand this part. So this is a gap in between. So this will insulate both of these sides from each other. So if I want to connect this next resistor, just put it inside, and here we got the connection between two of these resistors, and we can put take out this from this side, two extra points, and we can power it up, or we can add a diode or some other electronic component to it. So this is how a basic connection is done. But in a normal condition, I don't really like this way, because of these extra bulky part. because when I'm building a very big circuit, then this could be very hectic and sometimes make me confused, and it's hard to operate with this kind of things around. So the best way and cleaner way to do is to use a breadboard connectors. So let me show you exactly what a breadboard connectors is. So these are called breadboard connectors, and these are very helpful to make a cleaner circuit. And here you can see there is already an insulated and open part in this small connectors here. So let me give you a very close look to it. So you can see this this is the open area which could be connected to the breadboard on the top of breadboard, and this is insulated area. The best feature about this is when we are putting it on top of the connection. Let me just put it here. So I just need to adjust the next resistor here. So here, look at this. I have made the same connection that is off with the breadboard, with the breadboard and a jumper wire. Let's do it again. And here you can see. So you can see the difference. This is much easier compared to this one, because because of this bulky area, I cannot see a very large circuit if I'm working on a very large circuit. So these are much preferred when you are working with a larger circuit, and these are very important if you are working in a better prototype, because when we are going with extra length of wire, we are also introducing extra resistance, or it could be have more noises. And most of the time it happened that quality of this kind of jumper wire is not that good, and it could also give us some hard time building some circuits around. So they also provide noises, they also provide extra resistance. Sometimes there is a break in between, and sometimes they don't even conduct the that amount of current and voltage around the circuit. So it is very important to have this kind of connectors. These are very good, these are better compared to this kind of jumper wire. But if you are working with a smaller circuit and if you want to go with a cheaper alternative, then these are better. So you can choose based on your requirement, and this is how a breadboard works, and this is how you made connection with it. So after the breadboard, there is another kind of prototyping board that most of the time we use, but they are more fixed. Those are called perf board. So these are called perf board. There are different varieties of these. So for example, I could have this green one, which I have already built circuit on top of it. So these are not very much reversible. We can also we can simply desolder this, or we can just take out this extra part here, but we cannot do it in a very reversible way. But these are also kind of prototyping board. When we are very confident about certain circuit, then we can build a small PCB or a simple PCB on top of this. So here these are called perf board. Here in the lower side you can see this shiny part. So these are copper pads, and in top of these we do solder our electronic component. And there are some different components that are used with the perf board. So for example, this bird stripe. So these are called bird stripe. So these are male bird stripe, and this is female bird stripe. So here you can see there are holes in it, and we have a male connectors with it. And we can simply, what we can do is if I have an, let's say, ESP32, and which have this kind of connection at the end of it, or any kind of microcontroller which have a male connector or male bird stripe on top of it, then we can simply put it on top of the our perf board. Just align it and try to put the shiny part on the lower side so that you can solder on top of it. So this is how we can put the bird stripe on top of our perf board, and we can simply solder all of these extra points that is coming out of it. So just solder all of these and try not to connect two of these points, because this will make short circuit between two of these points. So always try to insulate them. Be very careful when you are doing soldering in this kind of thing, because it may happen you accidentally short circuit multiple points here. So for example, this is the circuit I have already worked with, and I can simply put the ESP32 on the top of it. And this is the best example I could show you here, how you can use a female bird stripe on top of it. And this is another example of putting a male bus type on top of the perf board. So these are little costlier perf board, and these are much better and my favorite one because they have extra strength, and you can see the silver pad or the soldering pad is on both sides. So I does not I don't need to see which side have which side is solderable or not. So I can simply put the ESP32 on top of this PCB I have designed. So I just need to put it on top of it and press it down, and we got our ESP32 on top of our circuit. So this is a small circuit that I have built for one of my RC car. So let's get started with the first topic, that is a multimeter. What exactly is a multimeter? Multimeter is an electrical device that can help you, getting some quantities or electrical quantities like voltage, current, capacitance, sometimes frequency in different model. Well, this is a basic view of a multimeter. This is the cheapest one I have, and you can easily find this in under 200 rupees. And these are really good for some basic task. Almost all of the different quantities or electrical quantities could be measured using this cheap one. And you can also go with the better one, so where you can also get the different feature like it can also detect capacitance, frequency, and lot of other electrical factors. So what it actually help in is defining or finding voltage, current, capacitance, frequency, or continuity. Where there are other features like ampere or the AC voltage is also there. You can using which you can also measure that here. And here you can see what a multimeter looks like. And this is the cheapest one I have. So here this is the knob using which we can assign the multimeter what it should be working as. So here there are different sections. So first thing is the V, that is the voltage section. Using this section, we can calculate voltage between two terminals. The next section is the resistor section, or we can calculate the resistance of our resistors or different circuits, resistance of a different circuits. The next part is the continuity part. This tells you how exactly is the connection between two of the terminals is going on, whether they are connected or not. So using this, we can also check whether a diode is working or not. I will explain you what exactly is a diode. And this next section is the AC voltage section, where we can actually calculate that our those voltage that is coming to our home. And next is the ampere. So this is the current measuring section. So here you can see 2000 micro ampere, 20 milliampere, 200 milliampere, and 10 ampere. So this is very dangerous zone. Don't try to put it on only the 10 ampere zone and leave it there. So try to put it only there for 10 to 15 seconds, and after that you can just put it off, because it will damage your it could damage your multimeter. So this is how this AC part works. This will make it off. And here this is another section you can see here most probably. So NPN and PNP, these are used for checking your transistor whether they are functional or not, but they are not always useful. Lots of the time it happened that they shows false reading to me. But yeah, this could work for up to certain level. So this is really good. And here you can see there is two different probes here which are getting coming out of it. So using these two probes, we can put it between two different points, and we can check different properties of a circuit between that 2 points. So for example, let me show you a small example. So I have this lithium ferrous phosphate battery, and I have this terminal at the end of it. And let's try to check what is the voltage value of it at this point. So what I have to do is put the red one in the red one. You can do the opposite also, but the values would be in negative side. So I need to put the red probe into the plus terminal, and plus black terminal into the minus terminal. So here you would be getting a value of 13.2 volt, and I have set it to 200. You can set it to the lower one, but this set it to a range. that the amount of voltage that you want to measure here. So as I put it up to 20, you can see 13.25. So the amount of resolution is also increasing with it. And as I put it onto 200, you could see the resolution or the number of decimal reduced. And if I put it to very high volt, so that is 10,000, you can see it reduces to a very much lower. So I can just do it, and you can see it got 13.25 or 26 volt in it. So this battery has 13.25. And what if I do it opposite side? So let me put it black on the red one and red on the black side. So what I got here is the negative value or the negative polarity. So this shows a negative polarity of our battery. So this is how we can do it, and this is the simplest way. And next thing is the resistance. So in this resistance section, when we put it on this way, so let's say we have a resistor of, let's say, around 20k range. Then if I choose any of this resistor in my place here, so let's check what is the resistance of these two of these. Okay, so if I check the resistance of one of it, I just need to put the both of these terminal on between this one, and I just need to hold it up there. And so here you can see it got a resistance of 0.46, which means it is 450 ohm. So this is how we can do it. So 0.4k. So 0.4k, that is 400 ohm. So this is how it works. And here when I put it to a lower range here, so you can see when I put it into 2000, then the value is 470, or there is always will be some fluctuation in the resistance value. So it is around 450 ohm resistance. So the value of this resistor is 450 ohm. And the next part is the continuity part. So let me put it into continuity. So if I do it, and I can check whether there is connection is going between 2 points or not. So let's check whether there is connection between the one terminal or next. So you can see the beep sound. So what it actually shows is that there is connection between two of these. So using this, we can check whether there is a connection between 2 points or not. So the next important electronic component that is needed to be understand is the resistor. You may have probably seen resistor a lot of time in your life, and when we are child, we usually take out that RC card, and when we look inside a circuit, there are small some kind of this colored stripe little electronics part that most of the time we think it is a kind of tablet or something like that. So this is how the resistor looks like, and there are multiple color stripes on top of it. And this color stripe actually help you to understand the exact value, tolerance, or different other properties of a resistor. So what exactly is a resistor? Resistor is an electronic component which help in controlling or changing the value of current or voltage in an electronic circuit. So this help you change the value or alter the value of current and voltage in a circuit. So this the basic unit of the resistance or resistor is the ohm or ohm. So this is how it is actually indicated. So for example, if I'm talking about 10k ohm resistor, 100k ohm resistor, so these are 10,000 ohm resistor, 100,000 ohm resistor. There are different values of resistors, and different range of resistors are available based on different requirements. So most probably you are already familiar with this formula, and this formula, which is Ohm's law. So R is equals to rho, that is resistivity, length per unit area. So whatever the conductor we have, so for example, this is the conductor where the particular area is there given and the length is given. And if we know the resistivity, then we can find the exact resistance of a particular conductor or any kind of material. So next property is the Ohm's law. So using V is equals to IR, which is R is equals to V by I. So based on this value of voltage and current in a circuit, we can also find the overall resistance of a circuit. So this is how this basic formula works. Well, there are different logics, like for example, series resistance, parallel resistance are there. There are different applications which we are also going to see right now in this session. So these are the basics of a resistor. Now let's understand how you are going to read the color code of a resistor. So these are the values, or these are the, I could say, a chart. You can easily search this right now in Google, and just try to print it out and just stick in your wall. This help a lot of time because most of the time when we are not able to use the multimeter, then we can directly see the exact value of particular resistor using this table. So how to use this, I will show you right now. So here there are different characteristics here. So for example, the color part is here. So this color, what exactly defined is different color which you can easily find on top of a resistor, and based on this color there is dedicated number assigned to it. So what are these are the first digit, second digit, or third digit. This could be anyone. So let's say we got 4 different stripes, and first one is red, second one is the yellow, third one let's say it's a green, and last one let's say it's a gold. So this is the stripe we got here. Let's say this is just an example, right? And here you need to understand the sequence here. So always try to put a resistor in this way, and the first color, or the first color of the band here, let's say red. So first one decides the first digit. So first digit is assigned by the first color or the first stripe in your resistor. Second digit is assigned by your second color stripe. Then the third digit or the third color stripe is the multiplier. I will tell you what exactly it is, multiplier. And the last one is the tolerance. So let's say we got red, yellow, green and gold. So first one, let's say this one is red. Then red means its number is 2. So the first digit is 2. Then second digit, look for the second one, which is yellow. So for yellow, look for yellow, which means 4. So the second digit is 4. And after this 2 digit, the next digit or the third digit is the multiplier. So add a multiplier, that is multiplication sign here, and look at the color of it. So it is green. So look for the green, and you can see for the multiplier value, the value is 10 to the power 5. So 24 into 10 to the power 5. So here you can see 24 into 10 to the power 5. This is the value of the resistance. So we can say this is the value of resistance. But the last value, look at the last one, which is gold here in our condition. So you just need to go for the last value, which is tolerance part. So here you will find the plus minus 5%. So for gold, it is plus minus 5%. So 5% of 24 into 10 to the power 5. I'm using a calc here, or my calculator here. So this gives us a value of 1.2k ohm. So this is the value which could be more or lesser. So plus minus of 1.2 kilo ohm. So 1.2 into 10 to the power 3 is the value where this resistance could be, either that value more to this value or lesser to this value. So plus minus 5. So plus 1.2 means in addition to 24 into 10 to the power 5, we will be getting extra this amount of resistance or lesser this amount of resistance. It could be anything in between 1.2 kilo ohm. So this is how a particular resistance is calculated, and this is not always important. You just need to remember some basic resistance value. So for example, 1k, 10k, 200k, 150k. Try to remember some basic or very frequent use case resistance value. You don't need to require everything here, but it is good practice if you have a better memorization power. Then I suggest try to memorize this, and it's up to you. Now let's see two most important configuration in resistors, and most probably you have seen the series and parallel in your class 10th, 11th and 12th notebook, and mostly in the physics chapters. So here you can see there are two different combinations here. So first one is the series combination, of resistor. Second one is the parallel combination of resistor. So the basic understanding or the difference here in both of these circuit is that in series combination, we basically have the values of voltage across each of these resistor would be changed, or different values of voltage would be found in between all of these resistors. But when we are talking about parallel resistance combination, then the value of voltage, that is V1, V2, V3 across each of these resistor will be same, but here the current will be distributed on different based on different value on different branches. So the value of resistor totally depend on the value of resistance here. So what is the value of resistor current in that particular branch is totally depend on the value of resistor that is connected to that particular branch. So here for the series resistance, the most important formula that you need to understand is to find the overall resistance between all the circuit or the in this series circuit. Then we can use the formula directly, that is sum of all the resistance, that is R1, R2 and R3, which will give us R equivalent, that is the total resistance of the circuit. But when we are talking about the parallel circuit, then the total or equivalent resistance is given by reciprocal of each of these resistance, each of the resistor. So for example, 1 upon R1 plus 1 upon R2, 1 upon R3. So this will give you an equivalent resistance of the circuit where each of these resistors are in parallel. Well, there are conditions where both of these series and parallel could be mixed up together, but that will make everything little complicated, which we will try to cover up in later, and when we go with advanced circuit or little bit intermediate side of circuit designing, or when we are working on little bit or some advanced PCBs, something like that, then we can look into it. But for now, for the basic part, you just need to understand the basic part, that is in voltage would change across when there is series in resistance are in series, and voltage would be same when there are parallel, these are in parallel. Now let's understand the basic application of resistor and what exactly is a resistor and how we can calculate the the value of a resistor on based on the color code. As I already told you all the characteristic and how you can do that using the color on top of this resistor. So you can see there are color straps on top of it, and if you look very take a very close look, and here you can see the first color is okay, this is gold, so we need to put it on the right side. So always try to put a resistor silver and gold on the right side, and then try to read it out. So here we got the first color, which is yellow. Then the next color here is the violet, and the next color after that is the brown, and the next color is the gold. So first is yellow. So for the yellow, you can see the chart, it is 4. The next current color is violet, that is 7. 4, 7, so 47 in 2. Next is multiplier, so next is brown. So for the brown, the multiplier value is 1, so 10 to the power 1. So first one is yellow, so that is 4, 7 into 10 to the power 1. And with a gold tolerance, which is plus minus 5%. So we got a plus minus 5% tolerance, 47, 47, 100, which means 470 ohm resistance it is. So let's check out it on our multimeter, what exactly value it shows in our multimeter. Let's check it out. So you can see here it got a 5% plus minus tolerance. So here we got a 458, which is almost close to 470 as I have to 470 ohm resistance. So this is what this is how we can do the main reading using our multimeter instead of just going with the color code. But sometimes it's very good practice to learn this small values, and it is very helpful for you to getting these values using the color code only instead of manually checking all of these. So for example, if you have this number of resistors and you cannot check out all of these, right? So you can simply, what you can simply do is you can look for the color code and you can simply find the actual value of any of these resistors. You can buy all of these resistor set in a very cheap price. So I think this cost me around 45 rupees or 50 rupees in the market. So this is how you can, this is how cheaply these are, and you can try it out in your own circuit, in your own breadboard. And this is the thing about resistor. And next thing we are looking to is the application part. Now the another application of using resistor is to use them as a voltage divider. I have already told you the circuit how that we can do that, and right now we have our resistors which are having a value of 450 and 450, which we have already tested out already. So we are going to use this exact resistor, and we are going to divide a particular voltage into two parts. We have already seen that when we have demonstrated the voltage across each of these resistors when we connect them in a series. And let's try to do that exact thing again. And again we are going to connect it with our 5 volt. That you should try it out again from your side. And this time next thing is the ground, and here we put it on the one of the terminal, and next is on another of the terminal, and we will check it out on our multimeter. So let's use our multimeter here, and yeah, so here is our multimeter. Just put it on the voltage calculation in that particular node, and we can calculate that voltage across both of these is 6.60, and let me just make it correct polarity. So, and the next one is 3.29, and the initial one is 3.3 something, so almost same. So here we can put some resistors in between. Let's say we want to reduce this into further one, or if we want to reduce this into more lower one, then what we can do is we can add extra resistor into it, and let's try to operate a LED with it. So let's put another resistor. I'm on again taking another resistor here to make it lesser, and the voltage drop across it would be much better one. So here we have, and let's connect the terminal across it, and let's check the voltage in between each of these. So right now we have 3 of these resistors are in the parallel way, so in the series way. So let me zoom it in. So 3 of these are in series. So let's check the voltage across each of these. That should be same as that of our the previous one. So we are going to check it. So it is 6.6 ampere voltage across each, and when we do the calculation across one of these, so that is 2.2 voltage. Sorry for the invisibility, let me adjust it a little bit. So here hopefully you could see it. So now when we do the voltage checking across one of it, so we got 2.2 volt, and again 2.2 volt and 2.2 volt. So we can easily put an LED in between these. So I have some LEDs in my stock. If you have these LEDs, so you can put some of these to make the overall got our LEDs lighten up using these resistors. And we have built a small voltage divider circuit, and this is how we can use it in our small circuit. And you can also have this in your in your own way, and you can try to build this exact circuit using your own resistors and breadboard. And this is really amazing to see something applicable, something that works, something that, you know, that is actually visible out there. So after resistor, capacitor is another kind of electronic component that is you could have already seen a lot of time even in your ceiling fan, because these are useful in those conditions where there is a requirement of any burst energy or burst amount of energy to be stored and delivered to a certain type of electrical devices. So, a capacitor is an electronic component that is using electrical circuit or electronic circuit to store energy. And the basic unit of the capacitor is mostly the farad, and you may have already heard of it in your class 12th or in your school time or school books. So the common unit for the common kind of capacitor you could find is microfarad, nanofarad, and picofarad. These are called capacitors, and most probably you have seen a capacitor of this size and this black cylindrical object. So these are called capacitors, and this one here is 470 microfarad capacitor, and they have different ratings. They have microfarad, nanofarad, picofarad. So they have, for example, this one here is 100 picofarad, which is very small capacitor, and it's been very quite time I haven't used one of these, and these are basically used for storage of energy in a circuit. And we use this in order to provide decoupling of some noises, or most probably you have seen this kind of capacitor if you have ever taken those RC car motors, and at the end of those you may probably found this connected with it. So what they provide is they provide decoupling with external noises and electrical noises. So let me show you an example of how these big capacitors are used. Let me let me show you here. Let's power this circuit up, and right now I don't have the SP52 connected with it, but still the capacitor would be charged. So I am giving it up a voltage of 13.5 volt. So I am going to connect it for a little while and let it charge. And yeah, so after this, let's take, and when we take this connection off, most probably in all other circuit, this would, if this capacitor won't be there, the voltage across this should be 0. But let's see what we got here. So when we connect it, you can see we got the 13.17, which will, gradually decrease as we are draining some amount of energy from it. So you can see it is not connected with the circuit, but still it has this amount of voltage stored into it. So this is how a capacitor helps, in reducing or any kind of sudden burst or sudden fluctuation in any kind of circuit. So this is how they actually reduce that. So after the resistor and the capacitor, another important electronic component is the diode. Where diode is a semiconductor device, a little advanced thing than those normal resistor thing. So it may look, it looks like something more like a resistor, but it does not have any type of color stripe, except one color stripe, that is silver stripe. So if you look at it very closely, you will find that there is a silver stripe on other side. What this actually indicate is that this is the direction of current that would be flowing from. So from this side to this side, the direction of current would. And the basic symbol of a diode is something like this. So this is the arrow which is showing what is the the direction of current, and this represents the silver stripe. So this is how a diode is represented, and this is very used in a lot of things, lot of application are there. And this is, I could say, one of the best application of semiconductors. Most probably what exactly is a semiconductor. So here this one is called diodes. So here you can see what a diode looks like. So here you can see a bunch of other diodes I have. So here you can see if you look very closely, the silver stripe on top of this side. So what this silver stripe actually shows you is that what is the direction of current that will be flowing, or what is the direction of polarity that you should be doing here. So this silver side always go to the the ground, and the non-silver side goes to the plus side. So what this do is it will take all the current in this direction only, and no current will flow from this direction to this direction. So there will be zero polarity, almost zero polarity, not exactly zero, because there will be some leakage current going inside this. So all the current will be going in this direction. Sorry, all the current would be going in this direction, or so all the current would be going in this direction, and there will be almost zero current flowing in this direction, except the leakage current. So this is how a diode works, and let me show you a small experiment with our breadboard. So grab your breadboard, and this time we have already built this voltage divider. Let that circuit be there, because this help us a lot, because we don't have a 3.3 volt exactly, or 2.5 volt to run this small LEDs, because going with a higher voltage would burn it up. So try to have this same circuit around that voltage divider, and grab any of your LED and connect it with at the end of it. So here I am, I just made a small gap between, and use this diode. So I have this diode here. So try to put the silver whatever, wherever the silver side is. So try to put the silver side in your right side, or this resistor side. So put it in this way. So let's make it something like this. So always put the silver side on this side, or the right side, or wherever the LED you are connecting to, and we made this or complete this circuit. So right now there is two resistor, then a diode in between, and then there is a resistor. So right now I want to put this LED here in the last resistor, and always try to see the polarity. So we are going with this side plus and this side minus. Okay, so always try to put the LED terminal in a correct way, because this could blow it up. So right now we are going to connect our power supply. So again, I have this 6.5 volt. So I'm going to connect it with the one of the terminal and the last terminal here. So here you can see the LED is blowing up, and you can see that right now all the connection is almost same. There is no effect to the the blowing of LEDs at all. But if we just flip this diode on the opposite side, let's see what happened. So if I put the the silver side on the opposite direction, just opposite direction of what I have done right now, just put it there in that way, and you'd find that the LED is not growing at all. So it is not glowing at all. So you can see that when we flip the diode on opposite side, there is no current in this direction, or there is no current in this direction. So this means that the diode is only allowing those current which is in a forward direction, or we call this as a forward bias, and there is no current in the reverse bias. So if we flip the diode in an opposite direction, then there will be no current except a small, very small, minute leakage current would be there. And when we flip it again and put the silver on the forward side, this will make it forward bias, and the current will start flowing again, and the LED will glow up. So you can see right now the diode is on forward bias, or the silver side is on the the flow up direction, or the silver side is on the ground side and the non-silver side is on the positive side. Now the LED is growing, or LED is glowing, sorry. So this is how a diode works, and this is the one of the simplest application you could have with a diode, and this is how you can use a diode in your circuit. Well, there are different type of other diodes out there. There's Zener diode, tunnel diode is there. There is lot of different varieties of diode, and based on different application is there. But you need to understand this simple diode only. Overall, when you move on with the advanced topic in circuit or circuit designing, we will try to learn more on this topic. But for the basics and for starters, this is sufficiently enough for moving us ahead in this course. So this is all about this video. We have learned the basics of resistor, capacitor, multimeter, diodes. We learned the breadboard, how to use them, what are the different components, multimeter, the perf board, the bird stripe, the jumper wires, and other different things. So these are all the things that you should have very basic, or the understanding should be very basic on this. And over the projects, when we start building the real life project, then you will got to know that this and how to use this in real life. So I have shown you some of the real applications. Some of them are not, some of them may not be very clear to you, but over the time when we start building the projects, then all of this would get itself aligned into. So you will understand all of these in a sequential way. So this is all about this video. Hope you like this, and if you know someone who required this kind of video, then please do subscribe and do share this this videos to other, or if your friend or someone who required this. So this is all about this video. Over the time we will learn more onto it, and I am Vikas. I love robotics. See you next time. Till then, bye.